Okay, looking at problem 2.39. So in this one, we have a stone being dropped from a cliff. So let's see if I can get a, we'll draw a cliff here. Right, and we're dropping a stone. And it's going to fall straight down. My idea straight here is not going too well, but let's get our cliff. There we go, better. Our stone. It's under gravity. So we'll get our gravity here. This is falling straight down. And the time it takes to go from the top all the way to the bottom is delta t. That's 2.80 seconds. So we want to know how high the cliff is. So height is a position. What we're going to do is we're going to manipulate some things here so that we can get something that does this in height. We can use it at other points in time. No pun intended for time. So we're going to use our positional equation here. But we're going to do a couple things. First off, v naught is 0 because there's no initial velocity. We're dropping it. And when it hits the bottom, and it's finally done here, that's 0. So we have 0 equals 1/2 at squared plus x naught. And x naught's the height we're looking for. Right? The position at the top will tell us the height. So if we make this our 0 point, and we come up here and this is x naught, well, x naught will tell us how high the cliff is. So I'm going to subtract 1/2 at squared from both sides, and I get x naught. Now I'm ready to actually start substituting some things in. And what's nice is that because my a is a negative 9.8, and negative times a negative 9.8 meters per second squared times my 2.80 seconds squared is going to equal my height. This becomes a positive quantity. So I'll put this through on the calculator, and we get 1/2, negative 1/2 times negative 9.8 times 2.8 squared. Make sure I have no typos. I'm getting 3.84 times 10 to the first. So 3.84 times 10 to the first, 3.84 times 10 to the first meters, or 38.4 meters is the height of the cliff. Sometimes you'll see this called h, where x naught is replaced with h. But it uses our equations, puts it into a format that gets the information we need.